Okay, let's go over homework 3.3, number 9. Alright, so part A. So we're looking for the intervals on which the first derivative is increasing or decreasing. Alright, so we have to take another derivative. So it's going to be f double prime of x. Right, so derivative of x squared would be 2x. Right, and derivative of 4x would be 4. And derivative of negative 5 is 0. So that's that. So we're going to set that equal to 0. And we can subtract 4 from both sides to get 2x is equal to negative 4. Right? Then we can just divide through by 2 to get x equals negative 2. Right? Then we can just look at the sign of the second derivative. It's second derivative, the first derivative, the first derivative. So we look at the sign of this guy. And when x equals negative 2, so I'll put that here. Right? So we're going to examine the sign. So if you plug in something less than negative 2, for example, you can try negative 3. Right? So you put negative 3, it's going to be negative 6 plus 4, so that's going to be negative, right? Then after that, so plug in something bigger than negative 2, so I'll probably plug in 0, right? 0 plus 4, so it's definitely positive. So you have a positive sign there, right? All right, so we know that f prime is decreasing on the interval from negative infinity to negative 2, right? So it's decreasing from negative infinity to negative 2, right? And f prime is increasing when on interval from negative 2 to positive infinity, all right? Then part B is actually asking for the same question. So f is concave upward when derivative is positive. So you can see that second derivative is positive. So when x is let's see, greater than negative 2 and all the way to positive infinity, right? Concave down when the second derivative is negative. So from negative infinity to negative 2. Alright, then we're looking for the x values of the relative extrema, so relative max and relative min. So we have to look at the first derivative. So you look at the first derivative, and by factoring out the first derivative, which is up here, alright, factoring out, so it's x plus 5 times quantity x minus 1. Sorry. All right, so we set that equal to 0 to find the critical numbers. All right. All right, then so you can see that x is x equals negative 5 and positive 1. All right. Since we already found the second derivative, well, let's try a second derivative test. So if you plug in negative 5 into the derivative function, so negative 5 second derivative function, all right, then you have we actually don't need to compute the value, we just want to know the sign. So 2 times negative 5, which is negative 10 plus 4, so it's negative, right? Which means that so second derivative is negative, so you're looking at the concave down shape. So at the top, that's going to be the local maximum. So local maximum happens when x equals negative 5. All right. Then if you look at the second derivative at the positive 1, right? So it's a 2 times 1 plus 4 is definitely positive, right? Which means that at that critical number, it's actually concave up. So we're looking at that point right there. So that's going to be a relative minimum. So you put the x equals 1, you have a relative minimum. All right. Then find the x value of the inflection point. So you can see that we have to go back to the second derivative. Second derivative here becomes 0 when x equals 2. Then you can see that here's concave down turning into concave up shape. So this is definitely inflection point. So f has the inflection point when x equals -2. Right? That's it. I hope that this was clear.